how to calculate V from E, okay? And I hope you remember the equation that I wrote for you previously, that delta V, which is V final minus V initial, that's the potential between two different points in an electric field, okay, is equal minus integral between I to F E dot ds. So this is the equation that you have to use to calculate V from E. So you are given E, and you do the integration to find the potential. You can always use one of the potential, VI as your reference. So if you use VI as your reference, okay, and set it to 0, okay, VI equal to 0, then V final will be V, okay? So V final will be your V, which is equal to minus integral between I and F E dot ds, okay? Don't forget that you are using your VI as your reference. So that's how you calculate the potential from the electric field, okay? Now, let me apply this concept to how to calculate the potential for a point charge. For electric potential for a point charge. For a point charge. We have seen this before, but I just want to show it to you, point charge, in a different way. Yeah? Remember the way we defined V, it was U over Q, right? Okay, V at point P, if you remember, it was K Q over R. I'm going to show you again how to find this by using this concept here, the calculating V from E. Okay, so we start from this equation here. Okay, delta V minus integral of E dot ds. Okay, all right, minus integral between. So I'm going to, of course, I have to draw. Before I do this, I'm going to go from. I have a charge here, plus Q, for example, and I'm going to go from a point P. I'm coming from to infinity. Okay, to infinity. All right, to infinity. So I'm going to calculate delta V here. So my charge Q, is going to produce an electric field here, and that electric field is very well known. I know it, and I'm going to therefore do my integration. I'm moving in this direction. Okay, I'm going to infinity, and this is my electric field is here like this, and this is my ds. Okay, so I'm moving along this line from point P to infinity. Okay, and I want to calculate the potential at point P. So my V final minus V initial. So this will be at infinity, V at infinity, and this will be V at point P. Okay, that's how we are defining. My final will be when I am here. There's no other charge. This is the only charge which is available. Now I'm moving here. Okay, from V at point P to V at infinity. And we know that V at infinity is, let's calculate, let's do the calculation here, okay? This is equal minus integral, of course I'm going from P to infinity. I mean R here, okay? At point P, the distance here is R, okay? I'm going from R to infinity. And what is the electric field at that point due to this charge? Is K Q over R squared dr, okay? All right? That's the integral of EDS. I am replacing ds by dr, okay? My ds is the same as dr. I can write it like this. It doesn't matter, okay? And the electric field, and the angle between them is what? Is cosine 0, which is 1, okay? There's a cosine here, 0, which is 1, okay? All right. So KQ are constant. Then you have minus KQ, okay? Integral between R and infinity of 1 over R squared dr. Okay? I'm trying, my son, to find the potential at point P due to this charge. And you know it already, but there's another way. I'm using this concept to do that, okay? So, what is the integral of 1 over R squared? Is minus 1 over R, okay? It cancels this minus sign, so it will be K, Q, 1 over R between R and infinity. Okay? So it will be what? It will be K, Q, 1 over infinity minus 1 over R. You all agree with me here, huh? So what is 1 over infinity? It is 0, right? This is 0. And what is V? Then V, this is V at infinity, which is 0. Then V at infinity here is 0 also. And then it's a minus sign, and there's a minus sign. They cancel each other. So V at point P, again, is KQ over R. You see it here? KQ over R. Where R is what? Is the distance between the charge and the point where we want to find the potential. Okay? So this potential here, V at point P, can be positive if Q is positive. And V at point P can be negative if Q is what? Is negative. Be careful, my son. Okay? So it's a scalar, okay? I'm going to repeat again, this is a scalar, and the scalar can be positive and negative depending on the sign of the charge. So the sign of the charge is important. You have to put the plus or minus of the charge when it is given to you, okay? So the potential at point P is KQ over R. So my son, you can come here and take a charge Q, okay? And tell me what is the potential here at the distance R. The potential at this point is KQ over R at point P. If I put here R1, if I go to a point here, another point here, R2, a point P, and then V at point, this will be KQ over R2. You see that? So if you move away from the charge, the potential decreases. Of course, there's an electric field here, and don't forget, there's an electric field here everywhere. Okay? Electric field. So as you move away from a positive charge, the potential decreases because R increases. As you move closer to the charge, the potential increases because R is going to decrease. As you make the charge larger, the potential increase. As you make it smaller, the potential decrease. And remember that the units of this is what? Is volt. Okay, remember that. Volt, which is joules per coulomb. Volt. The potential is a scalar. Don't forget that, my son. Now, imagine you have a system of particles, okay? System. Let's go here, okay? System of particles. What does it mean, system? Now, remember, this is the electric field for a point charge, what we did now. Now, I have a system of particles, okay? Particles. It means I have more than one. Maybe 2, 3, 4, 5 charges, I don't know. So I have a charge here, I call it Q1, another charge here Q2, another charge here Q3, and another charge here Q4, etc. Okay? And then I want the potential at this point P. Okay, there's one point P here, and I want the potential at that point. So I need to know the distances. This is R1, this is R4. I need all the distances. There are important distances here. R2 and R3. And I can calculate the potential at this point. I am very happy here because it's not a vector, so you add them algebraically, those potentials, okay? V at point P will be what? K Q1 over what? Over R1 plus K Q2 over R2 plus K Q3 over R3 plus K Q4 over R4, etc. Okay? I don't know how many charges you have. If you have 2, 3, 4 charges, you have to add them algebraically. Be careful, my son. You have to take the sign of the charge here. If the charge is positive, you put the positive. If the charge is negative, it will be negative. And Vp will be either positive or negative depending on the calculations. So this is how you calculate the potential, electric potential at any point due to a charge distribution, system of particles, okay? Q1, Q2, Q3, Q4, and so on. Thank you.